Be a recording about how to use Multisim live online circuit simulator. I think I've already told you na because we don't have laboratory class on campus, the best thing again, I'm sorry. The next best thing that we have now is to use online tools in order to simulate circuits, because if we were to have an actual laboratory, we will simulate circuits using physical components. In the absence of such, we will explore this tool that is made available online. It's called Multisim Live Online Circuit Simulator, and you can go to www.multisim.com in order to check this one out, or you can just go to Multisim. Um, this is the UI, the first uh, page that you can see when you visit the website in multisim.com. So first thing that you do is you need to create an account, sign up if this is your first time and you haven't had an account yet. So what I did in the past is that I used my um, Adu email. So let me check if that works now. So as you can see in the screen, I have my Adu email, and I use this one for in order to create an account in NI Multisim. And yeah, you just have to create your own password. But when what do you call this? Just a word of caution, guys. If you are using a different device for this one, please exercise caution in using your login credentials, particularly your Adu emails. Please exercise caution in order for your accounts from your university to be protected. And also, as you can notice here, I'm using Google Chrome as my browser because I think Multisim has recommended Google Chrome to be its browser. If you have a desktop, then that would be better. But if you only have like some sort of iPad or mobile device, it will also work, provided that regardless of any device that you're using, you have a strong internet connection. Because I've tried it in the past, and the multi-sim online circuit simulator usually doesn't work when the internet connection is not that strong. So those are two what I call as prerequisites. One is a Google Chrome browser, and second is a reasonable internet connection or internet speed. So let's log in. Now this is the circuit that I've made in the past. This is your assessment one. I've used the 14 ohm resistors on this one. So this is where I also check your answers from the assessment, whether you have really come up with the correct calculations. And now that you've learned about multisim, then it's a good idea that you would use this tool in order to cross check your solutions from the lecture, assess from the lecture assessments. So I would like to create a new circuit. So this time we will explore um, what the online circuit simulator looks like. and we will also explore the relevant circuit components that we will use for circuits EE2165. So this is an empty canvas. This is where you will virtually pin the electric component, the circuit components. So this vast area here is what you call your workspace. And your circuit elements are found here. And if you find the workplace too small or too large, you can zoom in and zoom out over here. Going back to the circuit components, we have the what you call this, the ground node. We have three options here. If you just hover on this option on this side, on this what you call this button, and you will somehow long press, and it gives you the options from that drop down list. So we have the ground node. Over over at the top are some measuring devices. So this is where we will use the voltmeter and ammeter. So this is a device that measures voltage in the circuit, while this is the device that measures current in our circuit. Now moving on to the sources, these are your options. So you actually have a lot of options here depending on the whatever circuit that you need to simulate. But in our course, we only deal with DC voltage and DC current. So these are just the two sources that we will deal so far. Maybe later on, if you fancy to explore more, then you can just explore more. Okay? And these are the passive elements. Over here, we have the resistor, the capacitor, the inductor, so on and so forth. There are actually a lot of passive, circuit elements that you can find here, but in our again in our course, we will explore resistors, capacitors, and inductors. By the way, this symbol of two parallel lines for a capacitor is called a non-polar capacitor, which means that it doesn't have particular polarity. So this is where you find the resistor, capacitor, and inductor elements. So over here are some of the other circuit elements that you can find, but I don't think we will use them for this for this laboratory class. So let's just focus on this four uh, drop down lists, and the rest you can explore them later on if your course needs to, or if you fancy playing around the circuit simulator. So what uh, we will simulate a sample circuit problem. So I'd like to use the second question from our assessment number 3, which is this one. I hope you are already familiar with the circuit because this is the second question that I've given you from your third assessment. So this is a problem that involves Thevenin's theorem and maximum power transfer. So let's get on to it. First is, we can just select the DC voltage of 35 volts. So that is how you would place the circuit element. You just basically drag down from the drop down list, and then it pops up into your work canvas. So this is the symbol for a DC voltage source. The longer plates are the positive side, and the shorter plate is the negative side. So how do we adjust this one. So we have uh, several options here. We can rotate them. We can copy, duplicate them rather, and what do you call this? We can adjust the values. If we click on this default value 12 volts, we can adjust it so that it reaches 35. You can adjust up to increase it by a factor of 10, 140 volts, or decrease it by a factor of 10. But if you just slide it sideways, you can adjust it to the desired value. So in this particular example, we have 35 volts. So let's stick to it. And the next are some of the resistor networks that we fancy looking at the circuit. So we have the first resistor here. Again, you can just rotate it like this. You can duplicate it, and you can adjust the resistor value by sliding sideways or increase or decrease the resistance by a factor of 10 by hovering up and down. So, wait. So we have resistors here. In your assessment, all of these resistors will have the same value, those with stars. And I'm gonna select 35 ohms for this particular example. So we will slide it down first and then slide it sideways in order for it to reach 35 there. So we have our first resistor. Oh my goodness, what happened there? So we have a total of 3 resistors, so let's just duplicate them. The second goes here. Our single rotation would do good, fine. And another resistor right over here. So you just drag them around in order to get them in the desired positions. Now, let us try to connect these elements first. So, if you're gonna hover the cursor at any endpoint of these elements, you will see this connector symbol, and what you'll do is you just click on that connector and then connect it to the other end of the adjacent element. So you'll just connect them. You'll just connect them. But before we proceed, let us first add the current source, the DC current source. So that goes over here. So we have a DC current source that points upwards, and we have 5 amperes. In fact, you can just adjust it over here, 5.00. There, we have 5 amperes. And then continue with the connections. We have over here, then we have over here, then connect. And lastly, we have our sister here. Maybe we should try this one. or maybe not. We can just use the simple resistor for that one, but if you'd like to explore, then that's also fine. So this one will act as our RL, and our RL, let's say, is grounded to 10 ohms for now. So let's continue with the connections. And our circuit is almost complete. But before we we test run our circuit, we need to add a ground node. You can add it anywhere. I'll just add it here, there. Because the circuit will not properly function if you won't add the ground node. Now, which parameters are we interested in looking at? We have to measure the voltage here. So that's our voltmeter. It will measure the voltage exactly at this point, and then we will add another current meter right over here so that it will measure the current at this branch. So the current measurement here would be the current measurement on this entire branch because they are in series, right? So the next thing that we will do is we will play the simulation, or run the simulation rather. So if we will press this one, these two instruments, the ammeter and the voltmeter, will give us their uh, measurements. That's it. So as you can see in this simulation, when the circuit goes live, the ammeter reading measures 1.68 amperes and the voltmeter reading measures 16.8 amperes. So if we need to adjust RL, we should stop the circuit simulation first. So in the question of what if our RL is equal to 6 ohms, what will be our current and our voltage? So let's play it again after we have adjusted RL to 6 ohms. Let's run the circuit again. Alright. So these are our new values. If RL is 6 ohms, our current then is equal to 1.795 amperes, and consequently our voltage measures at 10.77 volts. So we need to stop that again. What if we adjust our RL to be 16 ohms? What will happen to our current and voltage? So let's run again. So there we have it. Our current goes up or down, I don't know. It goes up, or I think it reduced to 1.53 amperes, but our voltage definitely went up to 24.53 volts because our resistance has increased. And going back to Ohm's law, voltage is directly proportional to resistance. So let's stop the circuit simulation, and now let us increase the RL to 36 ohms. What will happen to our current and voltage? So we have I before the simulation runs, we have I at 5.23 and we have V at 24.5. Let's see if which parameters will increase or decrease. Alright. So this time I've noticed that the current has indeed decreased. It was 1.5 just a while ago, and now that we've rerun the circuit, it is now 1.186 amperes, but the voltage went up to 42.7 volts. So in our laboratory classes, we will simulate the circuits that we have solved in our lecture class, and with a few what you call this tweaks here and there in order for us to explore a bit more of the circuit elements that we have here in this circuit simulator. So that's it. It's very simple, but again, it requires you to use a Google Chrome browser. But if you have any other browsers and you want to try that out, that's also fine. I hope that it works. And second, it needs a stable internet connection. That's why I advise you to do the circuit simulations outside of peak internet uh, load hours. So you can do it in the morning, perhaps, or which whatever time that is. What you can notice that the internet is quite fast. So it depends on your location and several factors, etc. So I hope that you've learned something from this recording, and maybe next week let us try to simulate or at least leave you an assessment assignment to simulate several circuits at a time, because you can actually simulate circuits several ones at a time because it is super easy. So that's it for this recording. Thank you so much, class. And if you have any questions, please don't hesitate to send me an email, give me a chat, or leave a comment in our Google Classroom. So thank you so much and stay safe.